The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Big Data Applications from an Analyst Viewpoint. Our guest speaker today is Preetham Kanti Paul. He is co-founder and director, Products and Solution, Bridge I2I Analytics Solutions. Known as an innovative thinker, Preetham has led development and implementation of several high-impact and cutting-edge analytical solutions for Hewlett-Packard and General Electric. Preetham holds MS in Statistics degree from Indian Statistical Institute, Kolkata, and have played leadership role in developing the large analytics setups of GE, now which is Genpact, and a HP from scratch. He has experience of implementing analytics across marketing, sales, risk management, and operations. Preetham is leading Bridge I2I efforts in building technology and solutions to make analytics and big data accessible, affordable, and available for larger audience, and thus creating sustained impact for businesses. So, without further delay, I introduce you all to our guest speaker. Over to you, Preetham.
Thanks for the intro, Aradhana, and thanks for the invitation to speak. Hopefully,
Continue with the
next
presentation.
45 minutes as we talk through. You can hear me, right, Aradhana?
Loud and clear. You can please start.
Sure. Yeah, and thanks to all the participants who joined. Hopefully, the 45 minutes or 1 hour we speak today is worthwhile for all of you. As we talked about the agenda of today is really understanding big data from a business analytics perspective, and we'll talk about why you should be bothered, what's the current status today, and the huge applications it can really bring in today's world. At the same time, we'll also take a look at how big data initiatives are really running across the world and what can really derail the potential. It has a lot of excitement around it, but there are possibilities of it getting derailed, and we'll take a look at that and see how probably analysts look at those situations and try to find out solutions for them. So without kind of spending more time on the agenda, I'll move to the next page. Okay, so there are few changes which has really happened in recent years, in the last last 10 to 15 years, as the storage cost has significantly gone down, and not only the cost but also the size of storage has gone down significantly, which allowed all the businesses to keep more and more information, be it informative, be it not informative, be it apparently looking maybe a garbage, but still people can keep more and more information. At the same time, there are a lot of new technologies which has come, which allowed to keep this data in a much more structured way, which allowed better processing of data, which allowed probably a cycle of data to access to data being crunched to much smaller time than what it used to be at some point of time, which not only allowed people to keep the data but also allowed people to process the data more easily and make it much more accessible for a broader people in a much faster way. At the same time, on the other side, there had been few companies who made significant impact in their business processes through use of analytics. And I would say that they have only made impact. I would say their business processes were really based on analytics. to name a few like Netflix, Capital One, Marriott. They're really called as analytics competitors, a set of companies who creates their business model based on analytics and based on data. And at the same time, we have seen emergence of LinkedIn, Facebook, Amazon, and they are creating huge amount of data, at a day-by-day basis. And if you really closely look at their business model, it's really based on data. Now, few of these are huge changes to the world, and what it has really created in the world. Number one, the amount of data which all of us are talking about is going bigger and bigger. Whatever be the size of the data it was in 2012, it's going to multiply by 3x by 2015, and many of this data is pretty unstructured data, and a huge amount of information, be it kept inside the company in a structured set or in an unstructured set. Now that creates the second problem. While volume is one thing to deal with, the second aspect which comes is really the mix of the data which we are talking about today. Now, if you look at it, we all started with analyzing probably structured data, and there had been several amount of effort, a lot of academical work in how to keep the data in the best possible way, and we used to do big data warehousing implementation to keep it keep it there in a structured way in a much more smaller space. Then probably at this moment, if you look at it, the definition of data has changed significantly, or I would say dramatically. We are talking about video, we are talking about text, we are talking about blogs, weather information, a lot of sensor information. Now the data is moving towards more and more unstructured than what it used to be before, and there are studies which talks about probably 90% of such data which is there in today's world is probably created only in the last 2 to 3 years, and 80% of them is probably unstructured. And very interesting to look at is that probably even 2 years back, our IT technology professionals, we might not have even experienced such data, and hence we might not even know the best way to keep and analyze such kind of information. So again, this is really a huge change which is happening in today's world. Coupled with the two aspects which we talked about in terms of the volume of data increasing, and then in the mix of the variety of data, the third one, which probably is again, it comes in as a parcel, is really speed of creation of this data. Now, as we are talking today, in the next 1 hour, there will be several number of blog posts. There will be several number of people who will be writing, or liking certain posts in Facebook. There will be several number of photos will be uploaded. So you can understand the level of the speed at which data is created. And whenever you are creating data at that speed, the expectation is always that you can also take decisions at a much more faster than what you used to do, in a previous world. Now, if you look at unstructured or such kind of volume of data, the data can, the big two sources I would say in today's world, one is social and second is machine. And a lot of work in today's world has been probably, in and around the social data. We all talk about social monitoring. We all talk about social listening. But then there are a lot of other data which is getting created through machines. These are sensors, chips inside your car. These are the sensors sitting in the satellite. It can be the network data. I think if you look at the machine data and see it tomorrow, probably that will create the maximum or the largest amount of data of tomorrow's world. Now, staying with that is, I would say, the definition of big data. Again, different people define it differently, but for me, I see the same three aspects the volume of data, the variety of data, and the velocity at which the data is being created. But then when I look at it from a business analytics or even technology point of view, the volume really creates the question that, how do we keep such such a large amount of data? In what way, or the best way to keep this data? The variety creates the question that how do we make this data very fast accessible to people, because it should take a long time to do a data warehousing, put this data into a structured place. Maybe after 6 months, we make some analysis or some data accessible to a broader world. Now, obviously, as we are dealing with variety, we don't have that much time. So how do we really make it accessible in a much, much faster way than what used to do before? And the velocity, obviously, as I talked about, now question is that how relevant is your data or analysis if you really delay, giving your insights by maybe an hour. In some cases, maybe you are taking a decision at a split second. So it really, looks at technology or possibilities in a completely different way than what we used to look at probably a few years back. Moving to next, I will talk about probably one of the example of a healthcare company which is in Pennsylvania in US, and it's a very interesting company who has around 2.5 million number of patients, and they were trying to really decrease the number of times the patients are really visiting the hospital, because the hospitals did not have that many, that much of space and facilities. And they obviously, the other pressure they were always facing is patients were coming back and saying that the cost of medical management is really high. And what they really did is they went back, they looked at all the patient records, health records of all their patients, and they identified few of those high users, or the patients who are really needing frequent care, and maybe even putting a lot of cost or burden into their medical management. And they've identified few of those people, and they made them go through a virtual care management system where they don't need to come to the hospital for everything. They can be at home. There will be a lot of medical devices which might be connected to those individuals, and those devices will send a lot of information back to the central database of the hospital. And based on the pattern of such data, based on how such some of these vital numbers are really changing, somebody might be talking to them about a need of certain medication, or even if in extreme cases maybe a hospitalization. But that really significantly decreased the number of times some of these customers were really coming back to the hospital. Obviously, their overall cost of medical management went down significantly. Now, this is just one example of how big data and the data which is unstructured, which is much more real time, can really make a huge change in some business. Now, having said that, some of these problems, some of the things which we talked about are looking to be much more esoteric. But if I look at some of the traditional businesses which had been using analytics, for a good amount of time, namely like financial services, retail, consumer packaged goods, or even high-tech companies, they also have a lot of opportunities by using big data. And if I look at how and where the opportunities lies, it can be twofold. One, where it can enhance some of the current solutions which are already available, but because of the volume, because of you being able to create some of these strategies with a larger amount of data, creates opportunity. And the other cases is that without a big data, without the set of technologies, there are a few things which you cannot even think of doing. So it creates really greenfield opportunity for you. Now, for example, when I look at enhancing current solutions, Now, fraud detection when you're in credit card or bank is something which is happening for a good amount of time by the bank. But then right now, with big data solutions, they can make it self-learning. They can make it more algorithmic. They can make it much more faster. And they probably can deal with a larger amount of data than what it used to be. It used to be at some point of time. Retailers can probably test out their pricing and promotions much faster. There's a time when if you do a promotion, you wait for 7 to 10 days, you get data, you analyze, and you decide whether the promotion worked or not, and then take a call whether you need to change. But I think that world has significantly changed today. Same is the case for clinical trials, which is age-old practice, but then big data makes it much more explorative. You can try out several different things. You can probably also have a less impact on the subjects which goes through clinical trial. On the other side, there are a few opportunities which are absolutely greenfield. Like for an example, a lot of us really focus on social media in understanding, understanding reputation, understanding what customers are really talking about in social media. We did a project where we tried to understand whether a new product will really be successful based on social media metrics. Similarly, if you look at Amazon, look at Flipkart, or many other places, the online promotions and product recommendations, which is happening real time, needs analytics and needs a huge amount of data, and that cannot be really done without the type of technology which we talked about. Having said that, again, there are few which are I would say which are more esoteric ones, so to say, right? So I know people who are working on using the satellite data, and they're in warfield, and they're deciding on how the troop movement should happen, so that they have a lower chance of falling into trap or lower chance of falling into landmines. Many of the cars of today comes with sensors which keeps information about several vital aspects of the car, and people are using that data, which is like being created in a every time in a microsecond you are creating data. They're using that information to identify a chance of breakage or a failure, and doing predictive maintenance for those cars. And then there are companies, there are networking companies who are using this data and identifying and predicting the security risk or potential intrusion into the network. So I think the opportunities and the possibilities are really huge, and different companies are using it or interpreting the potential in different ways depending on where their focus lies. And I think it had been an area of research for most of the big firms, most of the consulting firms, and McKinsey did a huge study a few years back, and that probably is one of the reasons why big data became that much popular in today's world. They really estimated a huge amount of impact which big data can really bring to some of the businesses. Like for an example, they estimated that to US only in the healthcare side, if analytics is really used and big data is really used in the proper way, it can really drive impact of $300 billion upwards. Now, we are really talking about a huge amount of potential, but then with such numbers in place, there is a lot of excitement and awareness around what we are doing, and there is a kind of expectation that big data can really change the world, and big data can suddenly make the world suddenly make the world different. But then probably in many cases we don't really understand the nitty-gritties and the complexities behind it. Now let us quickly have a look at based on various different researches, where are people at this moment in terms of adoption. Now, I think whoever you talk to today are talking about big data. It's a buzzword. It's being talked by every CIOs, CEOs. But then, Gartner in some time back did a study on, going back to many of these CIOs and CEOs and talking about where they stand on their, on their effort on big data. And they really figured out there is only 7 to 8% of these companies have really deployed big data solution to the fullest extent. And remember, many of those companies are the new age companies, like what you call as internet age companies. They are, their business is based on data. Their business is based on big data, and they really need to have a solution in place for running their business. But then, there are only 20% who is basically saying that I have probably, something, deployed in my within my infrastructure, but I'm still experimenting and not very sure whether it is going to work out. And there are another maybe 30% or 40% who are still building strategy. That they understand there is a lot of opportunity, but they still try to kind of figure out where to focus on and what business cases they need to really put money on. And then, there's still 35% of the cases where, people are not sure whether big data can really solve their problem. And that's a very interesting point, with the excitement and with I would say a more logical simplicity of solutions like social media, a lot of these companies have really, without thinking about what's best for such companies to focus on, have really invested in social media solutions because it looked more interesting, it looked more easier, or it looked more logical. And maybe more than 50% of today's big data study is around social media. But in many cases, people do realize that the type of insights which they're creating out of social media or similar kind of field is probably not really solving their largest problem at this point. And hence, what's happening is that probably many of those cases they're losing steam. And there's a company called Wikibon who have done a research in recent days, and they kind of came up with a number, a little shocking number. It says that at this moment, for every dollar spent on big data is only giving a return of 55 cents only. It's kind of debatable, no doubt. But then, what you can certainly take out of it is that there is a lot of explorations which are really happening in today's world. A lot of people are probably trying out something, failing. In my mind, there is, a large proportion of this money has really gone into infrastructure and data in 2012 and 2013. And in 2014, it will be very important to look at that data and see, how those data can really be used for, building strategies which can make significant business impact. So I think there is a lot of companies who are sitting on the fence, who are trying to think about that everybody is talking about big data and big data can change the world, but what exactly are the areas where I as a company should be focusing on in terms of making that maximum impact to my business functions. Now that really creates set of questions on are we spending in the right place? Are we doing it right? Do I have the tools and techniques which I need to make it work? And that really goes back to the next point, which talks about even there is a lot of excitement, and probably maybe 70 to 80% of the CEOs, CIOs are putting this big data and BI as probably one of their top 2 business priorities. What can really derail the trend which we are seeing today? Now, is it is it really that the world will move in its own way and everybody will reach reach the potential which we talked about, or is it that there are some places where there are pitfalls which the companies need to really figure out how to solve and then go ahead? And I see there are 3 different areas where today's challenges are. One, the availability of right kind of trained resources and business savvy managers. Why I'm talking about business savvy managers is basically because if you have to make some of these analytics much more explorative and business value oriented, there has to be a lot more adoption and excitement by not only the technologists, the analysts, but also the business managers who are consuming some of these numbers or some of these strategies and then using it on a day-to-day world. And that really creates a huge requirement of set of people who not only understands analytics but at least appreciates analytics, appreciates numbers, appreciates the impact which big data can bring to the table. On the other side, the question is really on technology, and I'll go into each one of them a little more. When I talk about technology, we're basically talking about, do I have the right technology for today, or is it really still changing? In today's world, it's really changing a lot. There's so much of innovation happening across the world that, on everyday basis, there is some new technologies which are coming up, and it's very difficult for any organization or any individual to really catch up with that. So it's a changing world today, and that itself creates uncertainty. And more importantly, as I said, a lot of effort, a lot of innovations, a lot of open source technologies has been made open source for probably data management, indexing, data, the querying part of it. And I think as we move towards more predictive stuff, that's where probably still there are more innovations really required. And the third part is more soft in nature, which is basically around the organization and the culture in the organization. Now, this is where it's very critical what we have seen in any organization for big data. It's going to be impacting several number of organizations. It's not several number of departments in an organization if you really want to make a business impact from big data. And we have seen probably conflicts rising in terms of ownership of big data projects from the technology team, from business teams like marketing, finance, and we have seen that being probably one of the major reasons why many of these big data projects of maybe 2012 and 2013 has not seen the level of potential they were expected to see. And that's one thing which is very critical for each of these organizations to create that collaborative and explorative culture inside the organization. What I'll do now is probably go a little more into the technology part as well as the people part. Moving to the technology, so the page here depicts one typical kind of architecture or ecosystem. Again, in no way the stack is really a recommendation, and it's very important that for a particular requirement somebody really thinks through and finds out what's the right set of what's the right architecture and set of tools which is required to be put in together. But then this is just an illustration, but what it says is that there are various components which are really coming in place for making an overall solution. The solution might need something for keeping the data in the best possible way, to being able to query from the data, to being able to create a data flow around it, coordinate between different structures. When you have structured data, unstructured data, when you have data which is voluminous or real time, non-real time, there are various different dimensions based on which you take a decision on what should be the right architecture you should put in place for your big data problem. Now, and on top of that, as I talked about, is a lot of this is ever changing today. And tomorrow, if we look at any of this, there might be a better solution available on any of these different names. And there are companies who are working on streamlining it. There are companies who are probably putting many of them together and creating a bigger, more commercialized kind of architecture and selling. But then, what's important from on practitioner's viewpoint is that it has a diverse set of components, and the expertise might not really reside with one person, and it might be highly distributed in nature. You might be having somebody who really understands how to keep the data in the best possible way, but then you might have completely a different person who has much better understanding of maybe machine learning to be done on top of that, on top of that architecture. So that creates a huge issue in terms of, what technology, how we pool all of these technologies together, how do I get the type of people, and how do I really bring together a team which can really, handle this complexity together. And on top of that, how do I really keep in touch with newer things which are coming in place, which might be even more effective than what we are seeing today. Staying on that point, going to the next page is, I'll just wait for the page to refresh. But this is like a very usual and simpler view of distributed processing, or maybe Hadoop kind of setup. And I know there have been a couple of webinars which has touched upon on what's Hadoop and how it works. And I'm not going to really go very deep into technology, because that's not the intent for today's webinar, and we can probably talk at length at a different webinar. But if you look at a very simple view which talks about how we take the data and kind of split it into different small pieces, in the best possible indexing, through a best possible indexing, and then how we map them together, how we put them all together again, and finally get some numbers. And now, if you look at it, this is like an example which has been beaten to death by several people, because this is probably the first project or first exploratory project which many of us do when we start working with maybe Hadoop, which is like creating the word count program, which is like number of times a particular word has really come in a set of texts. Now, you basically start with a large amount of text. You split this whole data into maybe several number of small machines, and calculate in each of these machines certain numbers and in terms of their frequencies, and then again kind of get them together and finally have a consolidated number. Now this looks, though it looks simple, but it might not be as simple as what it looks. But still, this is like a very simplified view of what distributed processing can be, because the problem in today's world might not be as simple as calculating number of times a word has come. Many of the problems of today, what's being really worked out, or in many cases what's being taught, is really related to counts and averages and sums, which because of its own nature makes it much more distributable. But then when you think about a more advanced kind of techniques like machine learning, like statistical modeling, that's where you have to really think through how you distribute that. It's not inherently distributable. Now let me see probably one specific type of problem in the next page, which we in Bridge I2I deal with. It's basically a credit card authorization systems. Now, as and when you swipe your credit card at any merchant's outlet, there is the data is really being fed into a decision engine, which has information about the merchant, where this transaction is happening, the type of transactions, a lot of information about that individual, type of things being bought, and that decision engine, for all practical purpose, looks through this data and takes a call whether there is a high chance of this particular transaction being a fraud transaction or not. And then it either accepts or decline, in some cases also refer, where somebody else kind of talks to you and checks whether the transaction is really genuine or not. And then finally, that creates a huge amount of data. You kind of track these individuals whom you have accepted and see whether some of them have finally resulted into fraud or not. Now, when you look at creating a decision engine like this, it basically is dealing with a huge amount of data. You can always take a small sample of the data, like any other statistics problem really deals with. But then when you take a very small sample of the data, what happens? Such frauds are not very common in nature. So you might not really get a good representation of data. And then with big data coming in place, with newer technologies, we can really think about beyond sample and probably use much larger amount of data. And we're talking about several terabytes of data being used, because every transaction, every swipe you make is really one point of transaction. The second part is that as you see, when you swipe the card, immediately, within probably few seconds, it takes a decision and tells you whether it's accepted or not. And hence, it has to be really an algorithmic solution. And the algorithm need to be really, taking the call in a much more real time. And it doesn't, you cannot really have an individual sitting and taking a call, because the whole world will stop otherwise. And the third part is that, when you talk about any of these algorithm, because frauds are changing, because every day people are doing newer types of frauds, it has to have a self-learning mechanism where it is learning from any new frauds which are coming and kind of updating itself. Now that's really a much more complex system in a big data setup. In the next page, I'm just waiting for the page to come up. In the next page, we're talking about what's the way we can really solve such kind of problem. Either using statistics or using machine learning. Now, one can be that you have some set of frauds, and which these are known frauds. So you try to figure out what are the transaction patterns which led to some kind of fraud. So you have the transactions which are frauds and some of them which are not, and then you try to figure out how they are different. And the second aspect is that what are the anomalies in the data? You know how people should ideally behave, and do you have an outliers which do not behave like the way others are behaving, and that kind of gives you a feel of what can be an outlier and probably potentially frauds. But then the next question which really comes is that it's not really a count problem. It's not really a sum or average problem. It's a problem where I have to, for all practical purpose, build some machine learning techniques to identify, to categorize data into frauds, non-frauds, and inherently, can that computation be really distributed? And how can we really make it much more self-learning so that it can pick up as and when new frauds are coming? Now that's where I would say a lot of newer innovations are happening or need to happen in next few years to come. Obviously, there are libraries like Mahout and others which many of us use, but then there are newer techniques. All of us are also finding out our own way of exploring and figuring out how such methods can be really distributed, and probably some of them will remain as IPs for many of these organizations. Hopefully, some of them will also be contributed back to the community, so that the community at large can really use some of these techniques. Moving to the next part, which is on the people side, and when you look at people side of challenge, as I said, there are two aspects. One, people who knows how to deal with big data, how to make sense of big data, and then second is having set of managers who can relate with some of these insights or some of the numbers which are being created by the analysts, and then be able to really use it in their business solutions. Now, and McKinsey 2 years back, or I would say maybe 3 years back, did a study where they talked about there's a need of additionally 1.5 million number of people who can be either generating insights or generating analytics within big data, or will be consuming as business managers. And so it's very important that we kind of look at both the groups and see, how the world is really dealing with those, challenges. Yeah. So as the next page kind of comes up, now this is like a very debatable question, and I think everybody has their own way of defining data scientists. But I'm just putting my own effort in terms of trying to say what might data scientists really mean. Now, in my experience over the last 15-16 years, what I've seen is there are 4 different, I would say, islands of skills which are important to make any business analytics, be it small data, big data, really work out. One, where somebody needs to really figure out what should be the right technology to store the data, to process the data, to make it accessible to a larger number of people. Then there are people who wants to know everything about the data, and they're like, they know the source, they know in what form the data comes in, they can make any data available whenever you need it. And then there are third set of people who loves to apply predictive techniques like statistics, machine learning, and for them, the idea is really how do I use some of this data, some of these techniques to solve certain kind of statistical or machine learning problem. And the fourth is really people who can relate with a business problem and see numbers and connect the dots between different numbers. Now, again, I mean, if I look at these 4 different islands, in my experience, I have seen people who have done extremely well being in their own islands and being really deep into it. And I have also seen people who have really diversified their their ability, and probably some people who got a good amount of functional domain knowledge, but at the same time pretty good understanding of some of the predictive techniques. So I think even in big data, these 4 islands will exist, because and probably something like technology and become much more important than what it used to be before. On the other side, what we'll see is that 15 years back, I used to, a month or so, people used to wait for us to really understand the data completely before I start doing any kind of analytics. Now we are talking about a variety of data today. New data will come every day, and we might not really have time for understanding the data for a long period of time, and expect that only an island will create that data and make it available to to analysts who will then start analyzing the data. Now, increasingly, what will happen is that we need people who might be very good at machine learning, statistics, but they need to really go beyond that. They need to get some view of technology. They need to get some view of where the data is coming from and the veracity of the data. What kind of complexity or problems the data comes with, and also can probably link with some of the business problems they're kind of dealing with. And I probably define them as the data scientists of tomorrow. But then if somebody asks me that is data scientist the only job which will be there tomorrow? Absolutely not. I think this is where we are putting a lot of expectation from a group of people who might have a little bit of kind of combined set of skills, but I still feel that there will be a stronger need of data stewards, because we're dealing with large amount of data and and very different data, and it comes with a lot of garbage. So we need people of that kind. technology is absolutely critical in big data. It is not going to be a separate island. Somebody has to work together to make it work. And then similarly, I think all of these different, there will be people who will be getting deeper in each of these 4 different areas. On the other side, when I talk about the other part of 1.5 million set of people, which is where we're talking about business savvy, analytics savvy business managers, I would probably like to kind of relate with the change we have seen in, in personal computing, handheld, that whole area where we have seen a complex laptop or even a desktop of the yesterday world moved into handheld, then moved into probably small devices, and it's basically kind of simplifying and make something much more available at any point of time. Now, in the same case, probably in big data also, to make more and more number of people really be part of consumption of some of these and feel really excited about it, we need to think beyond the complexities. I think complexity, I strongly believe that complexity is about solving questions, be it web, be it desktop oriented, which probably acts as a final front end for the business managers to simulate situations, to see some visualizations and take decisions, to look at how probably in a workflow how decisions can be really taken. Now that's where small applications with embedded analytics inside will be really critical. And I think Bridge I2I, from that standpoint, that's my company. We really work on some of those kind of aspects. Now that's a strong belief we have, that we need to have people who can solve the problem, but then we need to have technology for tomorrow's world which can make consumption of some of these analysis much more easier and much more simpler. Having said that, I would like to probably, I'm coming to the, final part. Maybe, we have around 10 minutes and want to keep some time for question and answers. And I'll be just summarizing in the whole discussion as I talked about. Big data is certainly, it creates a huge opportunity. It is really big opportunity, no doubt about that. It is real. A lot of people talk about whether it's a hype or not. It will be seen as a hype as long as we have more and more number of situations where traditional businesses have used analytics or have used business data, big data, and made some impacts to their business. While I think it's very important. But I think all of us need to focus on the right area, and I think there's a lot of effort which has happened in this area, but may not be on the most important area of focus for the business. As I said, just for the sake of joining the bandwagon, maybe a lot of the businesses have focused on social media, even though social media might not be the most important factor in their business. So they need to really focus on the right business case where they invest in. Innovation is important. As I said, world is changing. As any of our practitioners, technology people, we need to keep in, we keep a very open eye on newer technologies, tools which are coming on board. We need to simplify the outcome of it to make it much more usable and much more adopted by a larger group of people. And then finally, it has to be something which has to be interdisciplinary. A larger group of people should come on board. It cannot be an IT-driven initiative. It has to be a business-driven initiative, which really works out together as a group. Now, I don't want to take more time, but that kind of summarizes my thought, and I'll see whether there are questions which I can answer.
Thank you, Preetham, for the wonderful insight for this webinar. Can we start with the questions? You will find them in the questions doc. There are a lot many questions already pouring in,
Yes.
so if you can start.
Right. So I see a lot of questions on, even if I'm not a techie, how can I really grow in the business data world, big data world? Now, I think as I talked about, there are 4 different areas which will be critical in big data implementation, big data analytics. You will have the 4 islands which I talked about, and I think you need to probably have some level of depth in any one of these areas to be able to really contribute towards the big data world. It doesn't need somebody to be a statistician or a technician, a technology person, but then somebody might not be a statistician, but a technician, maybe a person who understands data, maybe who understands the the problems behind what are we trying to solve for a business. And I think it really depends on which area you want to really create your niche and depth on. But I see an opportunity for people beyond statisticians and technology people in this world. Now, I think some of the people are talking about how can I use big data. I think I touched upon some of the points on where some of these big data solutions are being used. As I said, a lot of these different new age companies like LinkedIn, Facebooks, and others, it's part of their business. They can't run without that, and hence adoption over there is much higher as compared to the more traditional companies, because they, many of them still have a lot of so-called, quote unquote, small data to still kind of deal with. But then, I think, I talked about a few of the places where some are really being used. Some questions are around life science vertical, use of virtual care management effectively. Yes, I mean, I think there are several examples where life sciences verticals are using big data, not only from the standpoint of virtual care. People are talking about, people are using it for better clinical decisions. I think obviously, in all the years so far, it is a subject matter, kind of decision, right? So a doctor comes and decides based on various different type of aspects whether somebody is having an ailment or not. Now, I think and they obviously take that call. They take certain levels of assumptions and take that call. And in today, a lot of companies, a lot of healthcare organizations are using that data to probably test some of the assumptions which are doctor, but just that the doctor might be taking several number of assumptions, and it might help them to validate many of those assumptions in a much faster way. How far the recommendation engines are really used and deployed as successful, I think it depends on the companies. There are companies like Amazon and others whose recommendation engine is one of the core aspect of how they really run their business, and they're known for building several number of algorithms, changing algorithms to kind of make it work. Again, there are a lot of companies where recommendation engine is not really a recommendation engine, it's really a recommendation system which starts with probably just relating business, they create business linkage, like, for an example, as simple as if you buy a toothbrush, you might need a toothpaste. You might not need analytics to do that, right? So, so that's what I kind of differentiate between a recommendation system and a recommendation, engine. A recommendation system is always required by a e-commerce business, because you would like to probably come across and talk about, show certain products, but only when you have algorithms in place which tries to understand that individual, that particular visitor, based on their previous patterns, based on other things they're buying, if you can really make a a personalized decision, then only your recommendation engine might really work out. So there are companies where it has worked out wonderfully, and there are companies who have probably not on a typical recommendation system. I'm just trying to kind of go through the question. Again, a lot of questions around what is the kind of knowledge gain experience one should possess to create a career. I'll go back and somebody can create career in big data in any of those 4 different areas. And I think it's up to an individual, but I think depth in one of them is going to be critical for being successful in the career for this. And I think a lot of people probably talk about data scientists. They'll be small in number, but I think data scientists will probably command more amount of progress because of the very fact that they'll be small in number in the world. But then there are a lot more other different ways people can grow in the big data world. Okay. People are asking questions around what is the difference between unstructured and structured data. Now, again, I mean, as an analyst, as a practitioner, I don't see that as a a huge difference. I mean, I see them as 2 different type of information available for me to solve a particular business problem. But then I think the way we keep the data, the best way to keep some data, the way we analyze the data, in majority of the analysis we do with unstructured data, we try to somehow summarize and make them structured fast before getting into an analysis. It's purely because the type of techniques, tools which we'll be using beyond that needs probably a structured data. So an unstructured data might need that additional process of summarizing and structure, creating a structure around it before it, understanding Hadoop, how it works, and probably dealing with the queries with like MapReduce query. And then, as you really understand that and how the data is really, data should be really managed inside a big data system, be it Hadoop, be it MongoDB, or any other NoSQL kind of database. I think that's probably a very critical stage for a technology person to understand how the flow will work. Then they can probably, always go deep into one of the areas. Like, they can, some of them might go even deeper into visualizations, into data, into querying. Some of them might go much more deeper into maybe predictive modeling or machine learning. But I think understanding how some of these systems really work is probably a critical aspect. Okay. I want to know the role of QA. Well, I would call this quality aspect in big data is going to be a huge aspect for tomorrow, and in few different areas. Like for an example, I think I talked about the 3 V's: volume, variety, velocity. But then several number of new V's are coming today, and obviously many of them are really creating more marketing excitement around it. But one of the V, which is veracity, is really critical. For an example, a lot of us used social media numbers and said, okay, 30% of the people talking negative about the company. Now, how do I really interpret that number? Depending on the type of company I am, my customers may or may not be that social media savvy, right? So, are they really representative of the data which I'm gaining out of that? is it really representative of my customers? And I might actually make a significantly wrong conclusion about my about me if I don't really take care of that the problem of veracity, the problem of the data being right. So that is one aspect. I think there will be a lot more scrutiny on the data. So that data is really being made available. As I said, I think it's changing significantly. A lot of the companies are using open source tools, and the interpretation of that, use of that, needs much more level of scrutiny before it really hits a person who will probably not understand the details behind it. So it is certainly going to create a significant amount of opportunity for all of them. Okay. Is Microsoft Technology supports it? Yes, Microsoft has their own big data platform, and many others also they're planning to support. A lot of people talking about I'm software engineer, wants to get into analytics. Yes, analytics is a larger field, but yes, I mean I think people are talking about what type of companies they should. I think it's not the right place to kind of talk through some of those points. But then I think probably I'm coming to the end of the time, and I do understand the importance of all of your time, and probably not go beyond. And somebody even asking about what are the good sources of problem statements. I think there are significant amount of research which is being done, several number of companies, and you can go into some of these and probably read through type of business cases which they're talking about. There's one study which was done by McKinsey. It's called Big Data Study. I think dated around 2000 or 2011. And there was an ASCOM study which was done a year back. I think both those two studies gives a very good idea about some of the business cases where the world is really focusing on. A lot more number of questions, but in the interest of time, probably I'll stop it here. And again, thank all of you for staying with me throughout this 1 hour. And thanks for inviting me. And hopefully it was worthwhile. Aradhana?
Have you got all the questions, Pritam?
Yes, Aradhana, I think there are several number of questions. I kind of tried to answer majority of that by
All right.
this, and maybe if required, I'll try to answer them in an offline way.
All right. So I request you, I will share the email with you so that you can answer them offline as well.
Sure.
Okay. So if you want to give a thank you note, you can do it now before ending the webinar for today. Anything you would like to say to the audience?
As we talked about no, I mean, as I said, no, thanks for staying with me for the 1 hour.
Right.
And thanks for inviting me. It was great interacting with all of you. Hopefully the time was worthwhile for all of you.
Yes, and due to time constraint, we are ending this webinar for today, and I'm really thankful to our guest speaker for conducting this wonderful webinar. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of the webinar will be available on techgig.com by tomorrow. Thank you all for joining us today. Thank you, Pritam, for taking time out. Have a great evening ahead.
Thank you. Bye-bye.
Bye, Pritam.